Yes, we can start. So, okay, I'm going to share my presentation. Hello, hello participants of this webinar. Uh, Welcome to this webinar. I mean, the title of this webinar is Digital Practices in the Construction Industry. My name is Abid Nadeem, and I am an assistant professor in the Department of Civil and Environmental Engineering. I think if you are not familiar with the Nazarbayev University, so, but yeah, I think only. Okay, so I guess you are familiar with the Nazarbayev University and the in the Nazarbayev University we are in the School of Engineering and Digital Sciences, and as I understand, this webinar series is for the recruitment of new students, for the promotion of the new students, and therefore we want to introduce some of the things which we are doing over here, and some of the concepts and emerging technologies are being introduced in this seminar to encourage the participation and uh, uh, and for the more promotion purposes. Hello, Lunaro. Will we record this seminar?
Yes, of course. We will record this seminar and upload it on our YouTube channel. At the end,
Okay.
I will send the link to all the participants who participated in our webinar series. Dear participants,
Okay.
you will get a special email with this information, and you can find it there.
Okay. So, yeah, are you recording it now?
Yes, recording has started.
Oh, recording has started. Okay. Okay, so and some introduction about me, and I am in the Department of Civil Engineering in the Nazarbayev University, and I have a certain a few of the web links on the website, so you can Google my name, and then you can find my background and research and teaching activities. So anyway, let's start the seminar today, and the topic of the seminar is the digital practices in the construction industry. Okay, so and the topic of this seminar is about the digital practices. So first of all, I would like to say that the construction industry is one of the largest industries in the world. It may be the largest one as well. So the global construction spending is expected to exceed over $12 trillion in 2021. And this type of industry has also a very large share of gross domestic products in many countries, such as in US and UK, it is about 6 and 8%. But despite this fact, construction industry is one of the least digitized industries in the world, which means that it lags behind in many other types of industries, such as manufacturing, aerospace, and the other industries, automobiles. So what is the reason for this lagging behind in the in the construction industry? So although we know that now in the construction industry, it is not very like it's actually quite common that the designers are using the digital technologies. They are designing in the 3Ds, and they are using the information-rich building information models to present that information. But is this the real digitization? Uh, the answer is not. The answer is no. The real digitization means something more than that. So we will talk about that more closer and real digitization later on. Uh, However, what some of the things which are lagging in the construction industry is that the construction industry is reluctant to change, and there is a lack of awareness about the digitization in the construction industry. And there is also often a confusion that if we want to digitize, or if we want to uh, make the construction industry more technologically oriented, of then how and where we can start it. So yeah, I think this is a question which is, of course, answer is difficult, but maybe one of the answer is that more real world examples can be demonstrated, and the uh, therefore can be demonstrated, so which will illustrate the digital technologies in the architectural, engineering, and construction industry, so that there is more uh, understanding and more propagation of the digitized digital construction concepts. So when we talk about the digital construction concepts, the first thing comes into mind is the concept of the building information modeling. Well, building information modeling alone is not the digital construction. Of course, there are some more things, but I will be starting with the building information modeling concept, which is called in short as BIM. So to understand BIM, maybe we can look at some of the definitions of the BIM. And if you will search the literature, you can find many definitions of the BIM, such as the one from the Wikipedia, one from the Autodesk company, the other one from the Graphisoft soft company, and then maybe one from the Bentley systems as well. All of these definitions use slightly different words, and then if you will read all those definition, maybe sometimes you may get confused about that. However, one of the main things defining the characteristic of these definitions is that uh, the BIM is one of the BIM uses the 3D virtual models of the buildings. Okay, so this is one of the common concept, or maybe the starting point to understand those different definitions. Having said that, still, if we take the construction perspective, BIM is fairly new to the industry. Uh, Although BIM concept has been there since 70s, since 1970s. However, from and the term of BIM being this increasingly used since the start of this 21st century. However, this type of period in this perspective of the construction industry is still new. So there are some standardization efforts as well. So for example, ISO 12911 and 19650 standards were issued respectively in 2012 and 2019 as well, which talk about the framework for providing specifications and the organization and digitization of the information as in the for the field of building information modeling. But anyway, when we talk, if when we look at the building information modeling from the perspective of the ISO interstandard ISO, the definition of the BIM is that it is a shared digital representation of physical and functional characteristics of any built object, including buildings, bridges, roads, and processes and plants. But anyway, having said that, we can agree on this definition of the BIM. A building information model is a 3D virtual representation of a structure or facility, which can also contain embedded information about that structure and its components that can be used to facilitate collaboration and information sharing in design, engineering, construction, operation, and maintenance. So uh, therefore, in this case, when we say that it is uh, two things which comes into mind when we look at this definition. One is the 3D virtual representation, and the other is the what I will say is the collaboration. Okay, so uh, building information modeling, BIM or building information model can be different for different people, okay? And in most of the time, and rather all of the time, it is the level of details that is the difference between building information model. So ideally speaking, uh, there should be one building information model on a project, but to achieve that one model, it requires a lot of effort. But in more practical situations, there are several models created by different stakeholders in the project, and then there's a need to integrate all those models into one model. So the reason for this integration of one model will be clarified later on. Uh, so a true building information model actually is not just the shapes, it is made up of actual parts and pieces and components. So that we will use to build the structure. So, well, a 3D model can be created by any software, any artistic imagination, and using some software, we can create a 3D model. But that 3D model may or may not be a building information model unless there is some additional information associated with the components of that model. Okay. So, for example, if we look at these figures, in this case, you can see that uh, there are certain components, and then these components maybe have some subcomponents over here, and then these subcomponents may be manipulated in different directions into the into the BIM model. So these are some of the characteristics of the BIM model. So you can play with, and you can rotate and place those components into different directions and places, so that we can these components can fit into the model. So that requires additional information in addition to the geometric information for the uh, which is needed to create the 3D BIM models. So once the 3D BIM model is created, that model can be then transformed into the 2D drawings, which can be used in the field operations. More views for the building information modeling. So this is so you can zoom in into the views. You can take different uh, components, and then if you want to see some components, then we can isolate that component and see it in different directions. And the components of the building may have some properties associated with that. So this is how the BIM, a building information model, should be. Okay, and then of course this is not all about the building information modeling. That is just one component of the building information model. Building information modeling is a whole lot of process, which includes some other things that I am going to explain very shortly. And you can see that the software like Revit and the other software can create 3D models, then it can be then extracted into 2D plan sheets. And the what is the data which is needed for the BIM is supplemented by the properties of the component libraries. These component libraries are created by different stakeholders. So, I mean, this is a big question. This is a big question that how the data is obtained for the building information model. So the data actually is obtained because this is a building information model facilitates the collaborative workspace. So therefore, with the collaboration of the other stakeholders, other trades, so the building libraries can be expanded, and then that's why, and in this way, in a collaborative way, the data in the building information model is populated. Okay, so the architect can create the original three-dimensional building information model, but the trade contractors would really have to add to the model. Yeah, so this is what that concept which I am talking about. Okay, so now let's talk about the level of the BIM adoption. So BIM has actually 4 levels of adoption. Uh, BIM level 0, it means that it shows little to no collaboration, and the output and information to the field in the form of 2D drawings, and those could be paper or digital. And BIM level 1, it uses a combination of three-dimensional models and two-dimensional drawings. And the 3D models are typically used by the design team during the design phase of the project, but the 2D construction drawings are used for review, permitting, and the construction. And BIM level 2 is actually a collaborative working environment. In this, the specifications are needed to include the information exchange process. In this case, the building information models or the 3D models are created by separately by the different stakeholders, different trade personnel, architects, structural engineers. But then these models are uh, shared with each other using the IFC file format, so which stands for the industry foundation class. And then each party still works in their own model, but they share the information in that standard format. Okay, so BIM level 3 is currently the highest stage of the BIM level adoption. It is a model where one model is used by all parties, not like different models like in BIM level 2 uh, and BIM level 1. So this level is sometimes called as the open BIM stage. So a deeper collaboration between all parties who is needed, who simultaneously work, contribute to a model that is stored in a central database. In addition to the BIM levels, we also have the BIM dimensions. Okay, so if we want to understand the BIM, then we need to understand the level of adoption and the dimensions of the BIM. So technically speaking, 2D BIM is not a BIM 2D, because BIM is always in 2D in 3D. So but still some components and uh, or to align with some of the definitions of the BIM, we may use a 2D BIM as well. So which is simply the use of the CAD and the digital drawings. However, although a 3D BIM is always uh, uh, proposed and promoted, but still 2D BIM or CAD or the use of the digital drawings is indispensable in many situations, still in many situations. The 3D BIM is the virtual model of the building, a site, road, or any facility that is drawn in 3 dimensions, and that contains other additional text information that's needed to build the structure. Whereas in the 4D BIM, time is added to each of the components in a structure, reflecting the scheduling data for the project. Whereas in the 5D BIM, additional information to visualize the project cost as a function of time as the project progresses. So it is being useful on a project that utilizes a true integrated project delivery approach. So such type of 5D or even 4D model will be more useful when an integrated project delivery approach on the project can be used, where the multiple stakeholders are in reality working for the same organization, or in a most collaborative way they will be working. And we may talk about 6D, 7D, but for all practical reasons, 6D BIM is probably the highest dimension. So it includes the project life cycle information. So this is sometimes referred to as the facility management model. So the model is created and updated by the trades throughout the entire construction cycle to include as-built changes and adjustments and traditional shop drawings information. It has the ability to capture data throughout the operational phase of the building. So remember that the 6D BIM can only be created, can only be useful than when we have at least these 4D or 5D BIM available. If we only have 3D BIM, and then that 3D BIM was originally created by the architect or even the structural engineer, but it was not updated throughout the life cycle of the project to reflect the as-built conditions. So then we may not be able to create that 6D BIM. So with this discussion in mind, so then we can say that the users of the BIMs are any stakeholder, okay? Usually the designers and the general contractors are the main users of the BIM users, but the contributions of the trade contractors such as the MEP contractors and reinforcing steel detailing contractors to use BIM for the work and then to add their components into the BIM model is indispensable for achieving the goal of 6D BIMs. And then later on, of course, uh, we need that the facility managers are also needed are also the users for the BIM, provided that a proper 6D BIM model is ready to be used. And then, of course, there are several more BIM users. So the BIM model development starts usually by the architect in 3D, and then other players in the construction industry, such as the structural engineers, MEP contractors, can add into those models, and the other trade contractors can also add their input. The architect can use the model to show the client, and then there are some other model development, such as in addition to the building information model, virtual reality and even the augmented and mixed reality applications can be used to further uh, uh, increase the applicability of the model for the purposes of the construction coordination, safety management, and constructability, resolving constructability issues, clash detections, etc. Uh, and but in but At the most basic level, uh, 3D to 2D plan review can be used for the permitting and review and the construction in the field. Okay. So this gives us the path to consider the virtual construction. So virtual construction is just like the is when we are going to talk about the 4D to 5D BIM. Okay, so in this case, if for example we can see the state of the project from different perspectives. Okay, from at considering the different planned situation. So we can identify the site management issues. We can identify the placement of the lay down area, material storage area, safety issues, and we can resolve many uh, uh, out of sequence construction activities, and many site management areas can be resolved by using the 4D and 5D, 4D, 5D BIM capabilities in the construction, and by looking at the model at different timelines. Okay, so that was something we talked about building information modeling. So recently there is a emerging discipline which is called as the digital twin. So the use of digital twins in the construction industry is quite recent, although other industries have been using those digital twin technologies for quite a long time. However, in the construction industry, the most use for the digital twin is in the property management and the facility management areas. So for example, because digital twins needs a very complete BIM model, a BIM level, an advanced stage of BIM level 2 or even BIM level 3 adoption, and then and then a 6D dimension of the BIM. So a lot of information is needed in the model. And in addition to that, digital twins also requires the constant capturing of the information throughout the life cycle of the building. So in this way, then we get an exact copy of the structure or the facility in the digital format, which can be kept monitored, and then can be used for the operations and maintenance of the purposes. And in addition, digital twins also will have their own software, which may not be the same as the BIM software. Okay, now I will briefly describe in the last few slides. Maybe it will take like 10 more minutes to complete this presentation. I will talk about the technologies which are not essentially BIMs, but still they are quite useful. So one of the use is the simple. One of the use is for the use of the digital drawings. Okay, not the paper-based blueprints which have to be carried. So the use of paper-based drawings may not be considered a good option in this area, because better solutions in the form of the digital drawings are available, and then these digital drawings can now be accessed very conveniently on the tablets, which can be used on the construction sites, and then one can do everything which one can do on the paper. And in addition, the capabilities for updating those drawings is tremendous, and the sharing of that information with others is also uh, quite handful. And therefore, those digital drawing technologies can reduce the rework as well. So, such digital drawing technologies are a Blue Beam Review. Okay, this is one of the software which can be used. And then there are two more web-based services which are called as the Plan Grid and the Field Wire, which provides additional capability for viewing the 3D BIM models in on the field, rather because normally the 3D BIM models are too heavy for the mobile devices. So we have to use them in the field of in the offices. So therefore, but those plan grid and field wire services enables the 3D enables the use of the BIM models in the field. So digital drawings. Then many of the field activities can be managed digitally. So for example, taking notes, and then using the construction management applications, and using the construction drawings and specifications. Uh, uh, so for example, the BIM files, there's a difference between the BIM use of the BIM file. So BIM files tend to facilitate the information sharing among project principals, and it does that at the office level. However, the construction management apps, such as the Plan Grid and Field Wire and the Blue Beam Review, they can be used right on the job site as well. Okay, and then their information can be shared among the job site people, and then they can be also uh, shared with the management level as well. So in this case, the facilitation in the resolving the request for information and the field submittals and scheduling applications can be made. One of the technology in this respect is provided by the Bosch tools, which says that which is named as the Refine My Site. So it is specifically made to facilitate lean construction and pull planning in the digital virtual environment. Next technology is the digital data capture on the job site. So this digital data capture on the job site can take help from the fillable forms, which are location aware, and this digital data form information can be easily shared. It is searchable, and digital photos can be taken very easily. And then, for example, one of the application, which is the called Holo Builder, can uh, take the photos of the digital sites of the sites, and then can stack those photos and well, and then it, a truly 360 degree view for the site can be created by using those technologies. Also, the use of the digital data capture. In the use of digital data capture, we can use the drone technologies or the unmanned aerial vehicles with the artificial intelligence application. So when we talk about the digital world, so artificial intelligence is a very hot area these days. So the drones carrying the cameras can use the artificial intelligence techniques to identify the problem areas on the site in the remote locations, or where in those locations where it is dangerous for the people to go to work, and then uh, that locations can be reached, and then the artificial intelligence capabilities, for example, some heat, the location, the problem areas such as the spillage of the chemicals, or the uh, safety hazard can be identified. Also, for the digital data capture, there is a technology which is called as the laser scanning. So, with laser scanning can create millions of data points, and then for the as-built facilities, and then it in a way helps to create the 3D models, okay, which otherwise may require a lot of effort to create. So, uh, so this is the 3D model generation, 3D model data generation. This type of technology can be used for the 3D model data generation activity. Uh, Also, there are applications of the robotics in the construction, and for such as the robotic total station has completely changed the way that the construction layout is done. So it takes its input from the building information model, so it is known where the things are supposed to be located, and the user simply walks around, and the receiver will tell them when they have precisely located something like the corner of a floor opening. And then we are also these days we are also listening about the use of 3D printers. Okay, so the buildings are now being started to be printed using the 3D printers. So this is the last slide of my uh, presentation. Uh, and then what we can see is that there are many carriers in the digital construction. I mean, okay, in addition to your degrees such as civil engineering, architectural engineering, and or other related disciplines, uh, you may be you may be expected to work in those areas such as 3D modeler, VDC consultant, BIM manager, and more. And you chance opportunities and your own aptitude. You may be working in with the drones. You may be analyzing data using the using the point cloud analysis in the and you may be even creating the 360 photography, and working in the hot field of architecture, artificial intelligence, and the robotics in the construction. And or you may even be working as an animation specialist to handle the enhanced visualizations in the BIM. So there are many career paths which comes into uh, reality with the use of digital construction. And the architectural engineering construction industries continues to adopt the technology at an accelerated pace. So the opportunities will continue to expand for careers in the construction. Okay, so this is the end of my presentation. I thank you for joining this presentation. And then if you have any questions, I will be glad to answer.
Dear Professor, thank you very much for the presentation. Dear participants, we welcome you. You can ask your questions. We welcome your questions. Please ask. You can ask questions about the admission process, about this topic, and so on. Please welcome.
Good afternoon. Thank you for the presentation. Very useful. We just recently on the job were thinking of 3D, of purchasing 3D scanning service. So it's very on time. The information is very on time. My question is, you mentioned a number of softwares that will be used for these technologies. Yeah.
Yes.
Do you teach any of these softwares on your bachelor's or master's programs at NU?
Yes, yes. Right now we are teaching a few courses. So one of the courses is the modern information technology in construction, and the other course is building information modeling in construction. So one is the undergraduate course, the other is the postgraduate course. So now these courses are offered in respectively in fall and spring semesters. So at present, these are the two courses which are related with the digital technologies in construction. And the software, these software are also taught in those courses, but not all, but maybe a few. For example, maybe the Bluebeam review, and that is quite useful, and then that can be taught. But the other software, for example, they may need some other some equipment also. So once we have those equipment, those software can also be taught.
Thank you. So one more question. So after this 3D scanning, I know that information can be transferred to the client in AutoCAD format. I mean, like in type of drawing, AutoCAD drawings format. And how is the cost data added to this, let's say, skeleton, to this 3D scan model? In which software?
The cost. Mm-hmm.
Yes, you mentioned that cost of the project, like materials,
Mm-hmm.
equipment cost, can be added on top of the design. Mm-hmm.
Yes, so so cost is related with the 5D capability. Actually, that 4D and 5D capabilities can be added simultaneously. So the cost and scheduling data comes from the planning and scheduling software such as the Microsoft Project and the Primavera Project Planner. So when you can integrate the data from your scheduling software into the BIM, then you can simultaneously create the 4D and 5D models. Okay, so from the 3D scanning, you create the geometrical information, and then that point cloud then give you some 3D model, and then you will add into that the information uh, from your planning and scheduling software.
And the pricing data also from Microsoft software?
The pricing data. It depends on the how we get the pricing data. So whether it is the actual pricing data, or it is some using some standard pricing. So there are databases which can be used for pricing the construction components. So for example, one of the database is the RS means online. and that provide some construction materials or construction assembly prices. So that the data can be obtained from those databases. However, from different countries' perspectives, so there may be some different databases. I'm not sure which database the Kazakhstan may be using, but they may have their own pricing databases as well. So the pricing data can be incorporated from some standard databases, or otherwise original prices could be obtained from the suppliers or the vendors, and then that data can be manually added. You're welcome. Yeah, any more questions?
Well, sorry. While the participants are thinking about the questions, I would like to announce that we will have the open house day in the format of a forum on this Saturday, 14th of November at 2 o'clock. Please come. We will have our startups, scientists from our researchers from our school. So I will send the information, the link in the chat box. Please read about it. We will wait for you. And now we are waiting for questions, please.
Okay, maybe just one last question. Do you believe that these digital technologies will replace standard design? I mean, or maybe in some countries it has already replaced blueprint drawings and
the total replacement of the blueprint drawings may not be forthcoming, but although it is recommended to at least replace those paper-based drawings to the more digital formats. So there is no actually there is no restriction. Uh, uh, there is actually no reason for using the paper-based drawings actually, on the job site. Not using the paper-based drawing does not mean that you are abandoning the 2D drawings. 2D drawings are 2D drawings in the digital format are still very useful and indispensable at the job site. However, that 2D drawings can be complemented with the 3D views, such as in the plan grid and field wire, as per the need of the project, maybe for the more complex projects. However, the use of 2D drawings, but not in the paper format, uh, rather in the digital format, is most recommended. So 2D, yeah, the paper-based drawings may still be used on the simple or not very complex projects, but for more complex projects, the use of paper-based drawings may not be recommended.
thank you very much.
You're welcome. Okay, so I think it seems that there is no more question.
Dear participants, if you have no questions, we would like to thank you for coming. You can find this webinar's record on our YouTube channel. It will be later or tomorrow or the next day. Thank you very much, Professor. It was interesting for the presentation. It was really interesting.
Yeah, you're welcome. Thank you very much.
Okay. Goodbye, dear
Bye-bye.
participants. Dear Professor, goodbye.